And this is somewhat custom implementation, I can say. Whenever suppose some of the companies, what will happen, they don't depend on any dependencies. They don't depend on any dependencies. But what is the basic criteria to don't depend on any dependencies? So I will tell you one of the disadvantages with this. So what will happen if you depend any kind of the library? If suppose TensorFlow having issues at the back end, my end users may lost their activity. So in this case I am going to be lose so much of money, and also the pressure, if I say, and also the pressure. So at that time, suppose you are working with some financial sector, so you are working with some CA, started accounts. So at that time they're going to be analyze some things, or you can say some GST or the CSD. They're going to be implemented at the last day of that. Suppose let's take that. So last day of that, so they're going to be finish their work until 12 p.m., or you can say 12 a.m. for that matter, 12 a.m. After that, next day is going to be financial year going to be starts. Next financial year going to be starts. So at that time, this is a very critical situation, I can say. This is a very critical situation. You have to be handled. Don't depend on others. This is a dependency, right? So don't depend on other models or other kind of the libraries. You have to be imported whatever the library you're going to be showcased with respect to the production environment, that maybe works out to handle these kind of the situations. So not only the few companies, most of the companies they are going to be implemented custom implementation, because of they're going to be satisfied with their work. Because you have to write some BRD in the showcase of don't depend on some other persons, or don't depend on any kind of the library. This is just for, I can say, if suppose you are just using the TensorFlow or any kind of the framework, you're just retrieving, that is fine, but you have to automate these models. So if once you automated model, then no one can stop you at that time. So if you not automated this one, it may not be possible to time to get resolved, or time to get resolved like this critical situation. So let's go and see some custom implementations. So we just analyzing the data with respect to whatever we learned, some different gates, forgot gate, and also the input and also the output gate. So let's also play around with this. So I answered some of the random variables. We can also see some random values according to that, and to get some matrix dimensions with respect to these input sequences values. So just importing that, and along with some of the gates, what are the different representation we are just showcasing on top of this notebook. You can see this information we are just retrieving with respect to the weight matrix, whatever we defined as a function with the different gates. And yeah, it's going to be written all these models, and we also go and calculated with the output results what we had. And the LSTM cells, I can say, so whenever you implemented and returning this function, or this much of the parameters what we had, so whatever the information you are going to be retrieved from this, along with the cell states what we had. So this is the each and every cell state with respect to the concatenation with some different activation functions what we had. So you can also retrieve the activation functions. We already learned sigmoid, right? 1 by 1 plus e to the power of minus x. You can try to implement that in the numpy, you can say. Then you can retrieve that information corresponding to the different parameters what we had. So yeah, this is very simple. If you understood this one line of the code, that is very easy to understand. Like different gates we are going to be implemented with different activation functions. And then you can see this signal model, and along with you can say whatever the information we retrieved in this RNN, you can say this RNN we just applied on top of this, that's it. So we're just taking that data frame and just applying on top of it. It's also eventually give good results at the end. You can also see with respect to the three different classes with some loss results. So whichever having the less loss, it's going to be give as a good results, or the predicted class. So this is a so this is a zeros, and this is a one, this is a two, like that. So if you just apply with respect to difference between the RNN and also something called as the GRU. So if you just play around with this, we can also see our GRU maybe in the next class. So I will also share these notes with you. You can play around with and try to analyze with regarding this data set, implementation of the RN and also the GRU. Which model is going to be get good results, which model not going to be get good results, and why not is not going to be good results. We'll try to understand in the maybe next classes so that